The last problem on the review says there are 256 players competing in a national chess championship tournament. The players compete until there is one winner. How many matches must be scheduled in order to complete the tournament? Now, when you're thinking about this, how many total games are you going to have in a chess tournament? Well, how many people play in a game? If there are 256 players to start, well, there's only 2 players per game. So that means there's going to be 128 games. So we're going to say A sub 1, our first round of games, is going to have 128 games. Now, only one winner can advance, so we're going to be cutting our group in half. So that means our ratio is going to be 1/2. Now, what we need to figure out is how many rounds, first of all, does it take to get to just one final game in the final round, the championship. So we're going to say A sub n. We don't know what n is. N is our number of rounds. We need to find what that is. But we know our last round is going to have exactly one game. Now, since this is a geometric sequence, we can just plug that in. We'll have the geometric sequence in general is A sub n equals A sub 1 times r to the n minus 1. Let's plug in what we know. So we have A sub n. We know that's 1. We don't know what n is yet, but we know A sub n is 1. Our first term is 128. Our r is 1/2, and that's being raised to the n minus 1. Now, the easiest way for us to go about this would be for us to start off by dividing by 128, and you end up with 1 over 128 equals 1 over 2 to the n minus 1. Now, you're probably thinking, Mr. Brasser, that doesn't help me much. Sure it does. The reason is we can actually change this since this is being distributed to both top and bottom. We have 1 over 128 equals 1 over 2 to the n minus 1. Because I didn't bother putting it on the top because 1 to any power is 1. Always. Any exponent you apply to, it's just going to be 1. And the reason I say that helps us is because now we can cheat a little bit. Oop, that's not my erase button. Goodness. We're going to just erase the top part. Because now we have 128 equals 2 to the n minus 1. Now you might have to go through and figure out 2 to what power gives me 28, or 128. So 2 to the first is 2, then 4, 8, 16, 32, 64, 128. So we end up with 2 to the 7th equals 2 to the n minus 1. Okay, why is it not showing on my screen? Let me zoom in a second. So we have 2 to the 7th equals 2 to the n minus 1, which means 7 equals n minus 1, or n equals 8. So that means it takes us 8 rounds total. Great, that wasn't what the question was asking. It was asking us how many total games are played. So I'm going to highlight this because we're going to use this in a second. So n equals 8, that's our number of rounds. And it's asking us for a total number of games played in those 8 rounds. So we need to do a series for this, adding up the total number in our first 8 rounds. So we'll have S sub n equals A sub 1 times 1 minus r to the n over 1 minus r. Now I said we're adding up the first 8 rounds because that's how many we have in total, equals, so S sub 8 equals, our first round was 128, times 1 minus our rate was 1/2. That's being raised to the n, so our 8th power, over 1 minus 1/2. Now, from here, I would just suggest punching this into a calculator. And as you're punching that into a calculator, I'm going to zoom in a second because it's showing a little funky right now. As you're punching this into a calculator, make sure you put your entire parenthesis, or entire numerator in parentheses, and your entire denominator in parentheses. And when you plug that into your calculator, you should get S sub 8 equals 255. And please include the units, because in this case, we're not talking about just 255 as a, whoa. Sorry, this is getting a little trippy, but we'll keep going. It's 255 games in our total of 8 rounds. Sorry that it got a little messed up at the end there, but hopefully it wasn't distracting enough to not get you to the final one.